The views expressed on Skeptically Speaking do not necessarily reflect the opinions of the University of Alberta, the Students' Union, or CJSR.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Hello and welcome to Skeptically Speaking. I'm your host, Desiree Shell. We have a fascinating topic planned for today. Transhumanism. Now, Wikipedia defines transhumanism as an international intellectual and cultural movement supporting the use of science and technology to improve human mental and physical characteristics and capacities. The movement regards aspects of the human condition, such as disability, suffering, disease, aging, and involuntary death, as unnecessary and undesirable. So that means that transhumanists are very interested in what's going on in biotechnology, artificial intelligence, and other human enhancements. So where are we in the quest to live forever? We have two people here to share their perspectives on it. George Dvorsky of the Institute for Ethics and Emerging Technologies, and Greg Fish, the author of the website worldofweirdthings.com. But before we get to that, it's time for another installment of Everything You Know is Sort of Wrong with Greg Laden. Greg is a biological anthropologist and author of Greg Laden's blog, Culture as Science, Science as Culture. Welcome back, Greg.
Well, thanks very much. It's great to be back.
So, as with all of your Everything You Know is Sort of Wrong segments, we're dealing with statements that people take for granted are correct. And it's not exactly that they're incorrect, it's just that they're more complicated than they seem on the surface. Is that a decent paraphrase?
Yeah, I think that is. I think that the idea here is a falsehood, as we're using the term here, is a statement that when you say it out loud, lots of people in the room will nod in agreement. And if you knew what was going on in their heads as they nodded in agreement, you wouldn't like it.
So today we're going to sort out the statement, humans evolved from apes. Now, one would think that the only people that are disputing that are perhaps creationists.
Right. That's one of the ways in which, and I guess I'd like to say that we probably should be thinking about the falsehood humans evolved from apes, and also the falsehood that humans did not evolve from apes.
Okay.
Both of those statements are, in my view, could be seen as correct, and they could both be seen as incorrect.
Okay, so people who don't accept evolution frequently fall back on the, well, if apes evolved from humans, why are there still apes? Unpack that, please.
Well, that would be one of the arguments. I mean, if it goes a couple ways. One, if humans, there's two problems that people would have. If humans evolved from apes, that means, number one, humans evolved. It means, number two, that humans are in some ways another animal, just like any other animal that evolved from any other animal. And it also may conflict with a certain particular person's version of origins of our species or of our kind, whether that's a Christian creationist or anybody else, it might conflict. So that's the main problem. But there's another side of this too. It isn't just that creationists don't want to hear that humans evolved from apes. That is a problem with the word human and the word ape being in the same sentence, linked by this evolutionary process. But evolutionary biologists also don't want to hear the phrase humans evolved from apes. And their problem is with the word from.
Let's just clarify, but our last common ancestor was chimps, right?
Okay, that's an interesting point. Let's say our last common ancestor was an ape. Our last common ancestor with other apes was an ape of some kind. So
humans evolved from a chimp-like ancestor.
Right. Yeah, and the word "from" here, it's really a problem of language. I mean, when you say "from," it's like the old problem where people say when they talk about African prehistory and recent human evolution, they say at some point humans left Africa. Now, to me, everyone was at the concert and then they left the concert means that the concert hall is now empty. It doesn't mean that some of them went home and some of them stayed and waited for the next concert. Humans left Africa means that everyone left Africa and whoever was behind wasn't a human, which is a very problematic kind of statement. Humans evolved from apes is kind of the same. It implies that there were apes and now there's humans and they're not the same thing.
Right.
People who teach evolution and who are evolutionary biologists interested in interfacing with the public don't like humans evolved from apes because it implies that humans are not apes. People want to assert that humans are just another form of ape, and that's the problem with the word "from." So the first level of falsehood is either the statement that humans did not evolve from apes as a statement that humans didn't evolve, or that evolution didn't happen, or that humans did evolve from apes, the problem there being well, humans are still apes.
Well, one of those is more true than the other.
Yeah, one of them is completely wrong. That's true. But there's another level as well. And this is the one that gets more complicated. And I think we have to sort of step aside a little bit and talk about like what is this conversation about? Other than the evolution creation part of it, it's about what are species and how do we define them and categorize them and classify them and so on. And it's interesting to point out if you want humans to have evolved from apes but to still be apes, then you have to say, well, what does that mean? Well, humans then would have ape-like characteristics. And what are they? And most people, when they think in their minds what the ape-like characteristics are, you mentioned chimpanzees before, think about chimpanzees. And that's because they're well known and everyone knows about them and they're always on TV and making commercials and there's TV specials about them and they're endangered and they're our nearest living relative. Okay. So that makes sense. But the word apes includes several species, the siamangs and the gibbons, of which there's many species, the orangutans, the gorillas, of which there's one species each, and chimps, of which there's two species. And on average, apes are small, suspensory, meaning they hang under branches, fruit-eating, monogamous primates, none of which is the apt description for gorillas, orangutans, or chimps.
Right.
So right there, we got a problem where when we say the word apes, we're using a word quite explicitly that means almost nothing that anyone thinks it means when they say it.
So is this semantics then?
Yes. And at that point, the answer is, well, what we mean is great apes, not just any apes, but great apes. We humans are a form of great ape. We're not like gibbons and siamangs. We're different. We're more like chimpanzees. And that's getting closer to what's probably true, and it makes sense. And the other element of this, which gets tricky, and this is where, teachers teaching evolution and only touching on this thing in the classroom, a lot of this falsehood discussion is really meant to help them, is the problem that if you have two living species that are, obviously have a common ancestor, it is very often thought, it's a falsehood in a way, that one of them might be like a living fossil or a primitive form and the other one's more advanced. And so you look at two species and you think of one as having not evolved, the other one as having evolved. When in fact, everything's evolving all the time, even if that evolution in some cases means staying the same. In fact, if you take two species and one of them has changed a lot, that's the one that kept almost going extinct, perhaps.
Right.
It's the one that wasn't that well adapted, so it changed or almost went extinct. So people will worry about, they'll say, well, our last common ancestor may have been a chimp, but you don't want to assume that it was a chimp just because you think chimps are inferior and humans are superior. That would be a anthropocentric mistake. However, when you do look at the actual evidence, it does seem that our common ancestor with chimpanzees was very much like a chimpanzee, like you said in the beginning. We evolved from a chimpanzee-like ancestor, as did chimps. They changed very little. We changed also very little for a couple of million years of our evolutionary, lineage. And then we made a couple of really big changes, so we're quite different.
So are humans more evolved than apes then?
We're not more evolved because we've all evolved. We've all had the same period of time over which our genetic code has changed. But it brings up another issue, which is maybe if people have a problem with the phrase humans evolved from apes because they don't want humans to be apes, and the counter to that is to point out how much we are like apes, although with a caveat that we're not like all the apes, just the ones we're closely related to.
Right.
We then come to the problem of, well, are we really like those apes? In other words, is it possible that just like we moments ago put great apes in a special category, we did not insist on calling chimpanzees the same word as you use for gibbons. We decided to put a moment ago, it was convenient for us to put great apes in a separate category from the lesser apes, although they're all evolved the same. Why can't we put humans in a separate category? Are humans different enough from the other apes to elicit being called something different? And here's where we come to the basic crunch between scientists who want to use taxonomy in a very pure cladistic manner, which would make it difficult to have humans be a separate thing from apes because we're within the ape group, and the pragmatic effects. Right now, for example, we are very comfortable with the idea of having a thing we call antelopes and a thing we call deer. They're related to each other, but they're separate groups, phylogenetically distinct. Deer have antlers, antelopes have horns. But if we take the group of animals that antelopes and deer are in and expand it just a little bit to include the bovids and the other bovids that aren't included in those groups and the pronghorns and so on, now you've got a group of animals that includes all these four-legged grass eaters and browse eaters and whales.
And whales.
Yeah, and whales. You got to include the whales in there. And it's, well, so to a cladist has no problem with that. A cladist is, well, that's just how it works. They diversified in a different way. And it's
What does a cladist mean?
A cladist is a person who uses the most modern techniques we use now to create a taxonomy that is exactly mirroring the actual evolutionary history of the organisms you're classifying, using a set of techniques that have developed over the last 30 years, 20 years, really. And basically what that means today is using the direct genetic relationships between animals. We have a classification system that is 400 years old, the Linnaean system, that puts animals into species and then genera and then families and so on. And that has created a sense of organization of animals that even people who study animals for a living are quite used to. And what I'm saying now applies to plants as well, which is I know more about animals. And the fact that there are like 7 or 8 species of lemmings in North America doesn't mean that a common ancestor exploded into 7 species one day in an evolutionary, event, but rather we classify all 7 species of lemmings into one genus. The number might be wrong there, and because they're like each other, it doesn't reflect the actual cladistic and genetic reality. Phrases like ape or great ape are like that. They're categories that have both taxonomic meaning, these things are related to each other, and adaptive meaning. The apes are not the monkeys. The monkeys are adaptively different as well as taxonomically different. And we are able to use the word monkey and ape. We're not forced to use the word primate. We're allowed to call apes apes and monkeys monkeys. We're allowed to call chimpanzees great apes and saimangs lesser apes. But in order to avoid human exceptionalism in our teaching, we're not allowed to call humans different than great apes, even if they are.
This is a much larger topic than one initially would assume.
That's why it's an interesting one, yeah.
So are we basically saying humans evolved from apes just as shorthand?
That's true. Actually, that's the good point, that even just the word ape is a shorthand, and it's a fairly complicated one. And in fact, as we pointed out before, the vast majority of people, when they think about apes in relation to human evolution, they really mean, not only do they mean great apes, but they mean African great apes. And so the relationship, the processual relationship of humans to the other apes, the phrase humans evolved from apes, is a shorthand. And the problem is it could mean so many different things.
Isn't this somewhat dangerous? It almost seems like using this kind of oversimplification kind of leaves the statement open to opponents of evolution pointing out the gaps.
It does that, and it also leaves the possibility that people can have a long, extended conversation about this and be talking about utterly different things the whole time.
So how would you word it then?
Well, I would say that I guess I don't have a pithy alternative because I think the problem is that it is pithy. Humans evolved from apes actually I like it as a shorthand because it's so bad. You can start with it and then spend 2 or 3 sessions in a classroom expanding on it and going back to it again and again so people can actually finally understand it. There's no easy way to make a really bad shorthand into another shorthand that's not bad. It isn't intrinsically wrong. There's nothing intrinsically wrong with a statement. It is intrinsically absolutely true or absolutely false depending upon the meanings, but the only way to restate it is to expand on those meanings extensively. So I would say that taxonomically, human beings, Homo sapiens, is part of the same group that apes are in, and apes are actually incredibly diverse morphologically and behaviorally. The living apes are a sampling of that diversity, which was much greater in the past and reflects almost as much variation as you have in primates. The living apes includes really tiny animals comparatively and the biggest animals that are counted as primates. It includes monogamous groups. It includes, I think you have to say that there are 4 different mating systems among apes, and they eat a wide range of foods and they have a wide range of behaviors. They live on 2 continents, covering the entire region that old world primates live in. They're behaviorally really interesting, and not even counting the humans as to where they live. And one of the features that they have is they managed to have spawned a species that is probably the primary cause of extinction of all of the other species that have existed in the last few thousand years of apes.
That is not pithy.
It's not pithy, but it's a little more interesting, and it's also a bit scary. You think about, there aren't any antelopes that are responsible for the extinction of all the other antelopes.
So if I say humans evolved from ape-like ancestors, am I simplifying it less?
The way to make that more correct and still almost as simple, and just to get rid of the other angle on this falsehood, is humans and chimps, or humans and the other apes evolved from ape-like ancestors, which almost is a tautology because you wouldn't, why would you say it that way? But you still have the problem in the way you said it, that humans evolved from. The word from is still there. Humans are a member of the ape clade, is correct. And the fact that it's a clade means that they are evolutionarily related to each other. It gets rid of the ambiguous verb.
I'm glad we sorted all that out, Greg.
Yeah. That could do it.
Totally settled now.
right? There would be no more problems.
Greg, thanks for being here.
Thanks. It's been my pleasure.
I look forward to the next Everything You Know is Sort of Wrong. And you can find Greg Laden's blog at scienceblogs.com/Greg Laden. And we'll be right back after this.
Skeptically Speaking wants you to question everything. You can email your questions for next week's episode to live@skepticallyspeaking.com, or if you're on Twitter, we're at Skeptical Radio, or use our handy question submission box on the website at skepticallyspeaking.com. After the show, continue the conversation in the comments section of the website, or check out our Facebook group. You can also subscribe to the podcast on iTunes, and while you're there, why not add a review of the show? Skeptically Speaking is rebroadcast at a number of wonderful radio stations. Check the media page at skepticallyspeaking.com to see if we air near you. And now, back to the show.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell, and I'm very excited about today's show. We're joined by two guests, and they're here to talk about transhumanism. We have Greg Fish. Greg is a computer science grad student and science blogger whose work appears on Business Week, Discovery News, and the Panda's Thumb. It's also been featured on Bad Astronomy, Seed, and IO9. He writes about unusual cutting-edge science and promotes scientific literacy and skepticism while researching artificial intelligence models and their applications. And George Dvorsky, a Canadian futurist, ethicist, and animal rights advocate, he's written and spoken extensively about the impacts of cutting-edge science and technology, particularly as they pertain to the improvement of human performance and experience. He currently serves on the board of directors for the Institute for Ethics and Emerging Technologies. Greg and George, welcome to Skeptically Speaking.
Hey, thanks for having me. Good to be here.
Great to be here, too.
So what is it about us that transhumanists are looking to improve exactly? Is it everything, or is there a focus on specific improvements?
I guess a strong case can be made that there's virtually nothing about the human condition that can't be, I think, altered or modified or changed in some way, I guess, to either change it for the better or to improve it. And that can be everything from how the body looks, how it works, how the organs function, through to the aging process, but of course even through looking into our reproductive processes, and of course very importantly our cognitive processes as well, whether it be our psychological state or whether it be things like our memory, concentration, and even intelligence. Where it stands right now as an organism that evolved through the processes of natural selection, we really got here to where we're at today through autonomous processes that were really unguided, if you will, by any kind of real foresight or with real precision. And it's kind of right now the human body is in kind of a good enough kind of a condition, and virtually every aspect of it is unoptimized. And that's really where the project now begins, is in a way we can kind of tip our hat to Darwinian processes and say, hey, thank you so much for getting us here to where we're at right now. We're going to take over now and kind of just kind of tweak things a little bit here and optimize the systems, the parts of the body and the mind that aren't quite perfect yet.
That's expansive. Greg, would you agree?
Well, in terms of being able to improve the human body or the human condition, there's certainly ways to go there, and I can certainly see how there would be room for improvement in a lot of things, especially in things like organ function and longevity. But there is a little caveat when you start messing with evolutionary processes. George is absolutely right that we're sort of just kind of good enough from a natural standpoint. And that's actually what evolution does. It produces creatures that are good enough to survive in the current environment. But optimization, especially in computer science context, for example, means different things to different people. What are you optimizing for? It's a very expansive thing to just optimize everybody for everything. And we are eventually gonna have to start making compromises. Well, we'll optimize for this and maybe not for that. Even more interesting is that evolutionary algorithms are actually very powerful because they don't have any kind of precognition. They don't necessarily have a name or a goal. We live in an environment where things are very unpredictable. So what we consider today's handicap might be tomorrow's advantage. Now, not that I think that necessarily living finite lives is an advantage, but actually I think some biologists would make the case that the longer we're around, the less genetic diversity there is because, well, we're probably not going to reproduce as often. We're probably not necessarily going to have the same genetic diversity. We might be more subject to new diseases that might take advantage of our existing weaknesses, whereas if we sort of let ourselves evolve, we would essentially be more resistant. For example, I can give one concrete case where we are evolving to cope with the current menace, and that would be HIV. There's a mutation in a gene called CCR5. I believe that's the correct gene, but it basically makes it extremely difficult for HIV to latch on to immune cells. And humans who have that mutation are extremely resistant to getting HIV infections.
So you would say that using different improvements and different enhancements would be a good idea, but we best be not fooling around too much.
Well, it's not so much that we don't need to be fooling around too much. I mean, if you're thinking that there is some supreme deity behind you about to say, no, don't touch that, then obviously you would think we shouldn't be messing with ourselves at all.
Right.
But in terms of us trying to sort of improve things that we know are hobbling us right now, that's definitely something we should explore. But we should be mindful that there is a point, and while we won't necessarily stop optimizing ourselves, if we have the capacity to do so, we should know that we can over-optimize ourselves to a very specific niche and basically hasten our own extinction that way.
Well, let's talk about some of the science and technology that are part of the transhumanist vision. It definitely touches on genetics and computer science, mechanical engineering, a lot of multidisciplinary work here. But let's start with nanotechnology. George, why exactly are transhumanists interested in nanotechnology?
Probably because our body is already infused with a lot of nanotechnology as it is. I mean, nanotechnology, of course, referring to mechanisms and entities existing, of course, at the molecular level. And just to give the audience just an idea of the kind of scale we're talking about, if you were to take a dime, for example, and take the thin side of it and splice it into 1,000 pieces, and then take one of those pieces and then slice it down yet another 1,000 times, you're now down to the nanometer scale. And it's quite remarkable to think that we're already working at this scale, putting together clumps of molecules and even having designers and early nanotechnologists trying to come up with these little machines that can actually work and function, basically according to the laws of physics and the laws of mechanics. Obviously, there's going to be some challenges working at that scale, and we may never actually, get to the kind of precision that we're envisioning. But we're certainly looking at nature as an example, and we can see, for example, that in our body we do have some examples of nanotechnology, whether it be things like red blood cells, and any sorts of the ways in which our bodies do work at the molecular level. So why nanotechnology is important is that it will give rise to a whole new sub-branch of medicine referred to as nanotechnology. And there's a nanotechnologist by the name of Robert Freitas who has spearheaded this, and he's come up with tomes of different ideas in terms of how we could supplement the body's functions with nanotechnological devices. And one of the more famous one is called a respirocyte. And what a respirocyte is basically an artificial red blood cell. And what it would do is supplement our existing red blood cells such that if somebody, let's say, had a blood oxygenation problem, whether because they have a genetic deficiency or whether they have a heart attack, for example, or, for example, if they're drowning in a pool, these nanobots or these respirocytes would take over and start to oxygenate the blood until rescue could happen or until the person could get regular oxygenation happening with their regular red blood cells. Or perhaps they could be switched on permanently, and you could have individuals basically deep-sea diving for as long as they want without the aid of scuba gear, that sort of a thing. There's other examples can involve such things even as the delivery of medications and so on, and this is actually even happening today. So this isn't really even rooted necessarily in futurism or science fiction. This is already happening pretty much in the current age. And there's even other potentials, for example, for cryonics. And cryonics is the act of preserving your body with cryopreserving gel in a vat of liquid nitrogen after you die, of course, in the hopes that future civilization will be able to revive you and integrate you back into some kind of future society. And prior to about the 1980s or so, we were freezing people, but we had no idea how we would ever bring them back. But that changed in 1986 with the publication of a book by Eric Drexler called Engines of Creation. And in this book, he basically, among other things, he chronicled how we could actually create nano devices that were powered by artificial intelligence, how they would suffuse the body and basically perform sweeping repairs in this degraded, or rather this preserved body, do cellular restructuring, and of course the most importantly would be in the brain, because that's the seat of consciousness, and set up nanoscaffolding, and of course the nanobots go to work and basically restore the cells exactly as they were when the person was still alive, in hopes, of course, of bringing this person back to life. And that gave the whole cryonics idea a lot more movement, a lot more traction, and it's still the moving paradigm going forward. So, as you can see, I mean, nano is really, really big for transhumanists, because it really does have the potential to reshape the entire body from the inside out.
So, Greg, what are some of the limitations here?
Well, the thing is, you can have nanotechnology as very effective treatments for a number of diseases. Actually, one of the George mentioned that they're being used to deliver medicine right now, and probably one of the more promising things that I've seen in terms of the use of nanotechnology is in combating cancer. There have been several studies where nanoparticles that were engineered to behave like viruses would attack tumor cells and release a snippet of RNA called siRNA, or small interfering RNA, and they would basically silence the mutation that would promote cancer tumor growth. So the idea could be that they would very actively suppress tumors, so they could be either extracted surgically or bombarded with radiation and destroyed. So you're basically stopping the progression of the disease. However, when we're talking about cryonics, which I also agree, it's actually an interesting idea and certainly an interesting experiment. One problem is that we actually haven't brought anyone back from being frozen. So we have ideas of how we want to do that, but we haven't actually tested out many of them. Probably the most successful experiments were bringing back cryogenically frozen dogs after about an hour. Well, we're not talking about an hour here. We're probably talking about a couple hundred years. And another limitation to create nanobots that would have the artificial intelligence necessary to put a frozen and possibly very badly degraded body back together is that, well, first and foremost, you're going to need to have nanobots that could work in those extremely cold temperatures. The physics at the nanoscale do change from what I understand. There are changes in what you can and cannot do at different temperatures. So what's going on is that you would have to have these nanobots coordinate with each other, where they are, what they're doing, how they're doing it. Today, a task like that would require a supercomputer to accurately figure out their positions within the human body.
And we're just not at that point yet.
Well, technically we could do it. I mean, you can program an algorithm that would keep them aware of each other, but there are two other problems that come into play. First is, how small can you make them before their motors will simply not work? It would be physically impossible to make them too small. And the other problem is, how would you be able to get enough of them into a human body? A human body has trillions of cells, and you would need tens, if not hundreds of billions of these nanobots in a single human body. And if you can't produce these very smart nanobots that sound like they would be pretty pricey to make, if you can't produce them for less than an infinitesimal fraction of a penny, you would be spending absolutely enormous amounts of money just to run a clinical trial. I mean, I did a couple of back-of-the-envelope calculations on something like this and came up with up to several $1 trillion to run an actual clinical study on about 5,000 people, which is a pretty average drug trial.
Audience, you're listening to Skeptically Speaking, and we're talking about transhumanism with futurist George Dvorsky and science blogger Greg Fish. If you'd like to know where we're going in our continual quest to be the best that we can be, email live@skepticallyspeaking.com or tweet us at Skeptical Radio. So in regards to nanotechnology, what we're basically talking about is not exactly enhancing, it's more about repairing. Is that correct?
Well, I think if you have the red blood cells that I described, the resporocytes, that's definitely enhancement. If you can hold your breath for half an hour or not even have a heart because your heart has stopped due to a heart attack and you're still alive, that's definitely an enhancement.
Okay, let's talk about what else we're doing about repair work, because I'm fascinated by this, because actually transhumanists are doing a lot for the disabled community. So let's talk about prosthetic limbs. Amy Mullins, specifically, is a brilliant example of this. George, can you just give us some background on her?
Sure. Amy Mullins is a former para-athlete and famously known for obviously having prosthetic limbs. And since retirement, she's been an outspoken advocate of not just working on behalf of the disabled, but working to normalize the whole concept of not just having prostheses, but looking at it as something that doesn't necessarily have to mimic normal human functioning. And this has been the paradigm, really, to this point in time in our history when it's been in terms of our approach to treating disabled persons, and that is we've had it in our heads that we need to make them as human-like or as normal as human-like as possible. And Amy's saying this isn't necessarily the case, that we can actually make us better. And when I say us, she's referring to the disabled people. And of course, for those of us who are in the transhumanist community, we obviously extend that to the regular population as well. And where this has really been, exemplified has been in another case where there's been a para-athlete, and that's Oscar Pistorius, the South African runner. And his story is a rather fascinating one, particularly in terms of where we're at right now in his story. This is the fellow who tried to compete at the Beijing Olympics and wanted to race along able-bodied athletes. And in fact, he did manage a preliminary race to race against able-bodied athletes. But the IAAF moved in and basically said that, no, this is no good, that his prosthetic legs are actually too good. What they're called are cheetahs. And they felt that they were giving him too much of an advantage, that he wasn't actually needing to exert as much energy as able-bodied athletes had. So they banned him from competing against able-bodied athletes. He, in turn, argued that, and a mediation court actually ruled in his favor, saying that the IAAF did not provide enough evidence to show that, in fact, he was given a distinct advantage. So he was, in fact, able to attempt to qualify for the Beijing Games, but he did not qualify, as every able-bodied runner was faster than he was. But the fact of the matter is now is that the precedent has been set that he can, in fact, continue to race with these legs against able-bodied athletes until the IAAF do some kind of more rigorous work in terms of explaining why he can't run. Right now, what the language states is that anybody with, and this is literally the language, it states that anyone with an assistive device that acts like a spring or has wheels or anything like that is simply no good. Now, this is what we're looking at though right now, are like first and second generation running prostheses. One can only imagine what's coming down the pipe in terms of third and fourth generation. And assuming that disabled runners will continue to want to run as fast as they possibly can, and I can't see why they wouldn't want to, I can foresee the day, for example, when disabled athletes will actually start to run faster than able-bodied athletes, and they'll start to smash able-bodied records. And in fact, the public's attention may start to gravitate more toward those types of events simply because they're going to be more exciting and more cutting edge. And of course, that now leads to a rather incredible possibility, is that you're going to have able-bodied athletes who will insist on having similar kinds of prosthetics, whereas they can actually look at their own legs now and say, my goodness, this is actually inferior to what sciences and technology are able to actually manufacture. And you can go to your doctor and say, look, I want you to cut off my legs. I'd rather have these prosthetic limbs so that I can run into the utmost of my capabilities. So it's an interesting model because it can be often. I find that sports is often paralleled in terms of real life. And similarly, what may happen here is that the disabled, and Amy Mullins is certainly an advocate for this, may provide the gateway for enhancement for the general population. That if the disabled can become better than human, or more able than the normal human, then why can't the regular population be that way? So that's the interesting story. That's what Amy is basically she's doing these days.
Now, Greg, is there anything that you're worried about?
First off, I have to say that pretty much everything that George mentioned about not necessarily seeing robotic enhancements or rather robotic prosthesis as a handicap is absolutely true, and we should certainly be continuing research into it because it benefits so many people. But the two things that I would be concerned about, but of course by concerned I mean in the sense that we need more research rather than an objection. The first concern would be to make sure that the actual procedures themselves are safe, because if we're going to have people who are able-bodied and who see an opportunity to enhance themselves with a robotic prosthesis, the procedures that are necessary for that have to be safe. They have to be sure to minimize the risk of infection. They need to be sure that the person could actually feel what's going on with the prosthesis. That's currently actually possible. There is technology that creates some sort of feeling or feedback. So all of that needs to be definitely up to par. And the second issue that I would be concerned about would be actually the reaction of those who are more technophobic, who would look at this as sort of a perversion and see, instead of seeing people enhance themselves and take advantage of the tools that they now have available to them, basically start an anti-technology and anti-scientific campaign in the name of preserving humanity as it is, whatever they mean by that.
We have an interesting audience question, a bit of a twist on that.
How does transhumanism handle the probability that technological advances will only be available to a small number of people? Are we assuming that the people who can afford this type of advancement will use it to figure out a way to enhance everyone else? Or are we looking at an eventual division of humanity into technical haves and have-nots?
That is like the default question that transhumanists are commonly asked. It's like the number one question with a bullet. And it's obviously a challenging question because that is obviously a concern, is the haves and the have-nots and who gets to have this stuff and who does not. And what I'll say to that is that basically what the caller there has described is the current problem. That's not a future problem, that's the current problem. And there's this assumption that we already have equal access to medical sciences and medical technologies, which is an absolute fabrication of the truth. We in the developed world are definitely spoiled. We certainly take for granted that we have access to things like vaccinations, that we can go to the hospital and be assured of having an MRI or an fMRI done, or that if we have some kind of debilitating disease or some kind of an illness like cancer, that we can have chemotherapy and other sorts of interventions. But that is certainly not the case in many other parts of the world. Yet at the same time, we don't say that, well, because they don't have it in certain parts of Africa or they don't have it in certain parts of Asia, or that there is that even across the entire globe that you have a certain class of citizens that don't have access to it because of monetary issues. We don't say that the rest of the people can't have access to it. That would be a rather harsh approach to say that, well, if everybody can't have it, then nobody should have it. Right. So that's the first thing I'll say. The second thing I'll say is, you know what? Absolutely. It's going to happen that only a select few are initially going to have access to these sorts of technologies. That's the way technology works. That's the way medical technologies work as well. But what I can say is that time will certainly be on our side. And this is definitely something that we're very concerned of at the Institute for Ethics and Emerging Technologies, is how do we make this stuff as accessible to the general public as possible? That's why, for example, we advocate for universal health care, which here in Canada, it tends to be somewhat of an easy sell, but the IEET, which is primarily based in the United States, it's not such an easy sell and becomes somewhat of a controversial platform. But it certainly is something that we're aware of, and we realize that as these technologies are developed, we need to agitate, and we need to progress forward such that everyone can have access to these things. But the idea that we should not develop them is I think, the dangerous approach to have. What we should do is develop them, absolutely, but at the same time work to make sure that they're accessible. That's typically how I tend to address that particular concern.
Audience, you're listening to Skeptically Speaking, and we're talking about transhumanism with Greg Fish, science blogger, and George Dvorsky, Canada's leading futurist. If you'd like to know anything about transhumanism, email live at skepticallyspeaking.com or tweet us at Skeptical Radio. And we'll be right back after this.
On the next episode of Skeptically Speaking, our guest is Ben Radford, columnist and managing editor for Skeptical Inquirer. Ben is a veteran investigator of paranormal incidents and the author of the book Scientific Paranormal Investigation: How to Solve Unexplained Mysteries. He'll share stories about his favorite investigations and the techniques he uses to bring real science to bear on paranormal claims. And on Speaking Up, we talk to Marcus Volter, host of the science podcast Omega Tau. That's next week on Skeptically Speaking, Friday night at 6 p.m. Mountain Time at skepticallyspeaking.com.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell, and we're speaking about transhumanism. My guests today are futurist George Dvorsky and Greg Fish of worldofweirdthings.com. So we've been talking mainly about kind of merging the biological with the technical. So might it just be simpler to do without the biological bit altogether, or lessen our dependence on that?
You can try, but it's probably going to be an uphill climb. And by uphill climb, I mean Sisyphean.
Right.
The problem with actually getting rid of the biological side of the human body, and I think we're venturing into singularitarian territory, into the realm of Ray Kurzweil that was sort of explored a little bit by Werner Vinge, who's the father of the technological singularity notion as we know it. The problem is that it's sort of assuming a mind-body dualism. It's somehow saying that we can somehow separate our consciousness, our personality, our thoughts, our memories, our dreams, our hopes, our nightmares, package it all into some sort of a format that we can put somewhere else, like a computer, for example. It doesn't seem necessarily to be the case, because we know people who have brain injuries can change their behaviors. People who have parts of their brain irreversibly damaged, certain parts of their brain irreversibly damaged, they change. They can change quite radically. They can lose their memory. They develop strange new abilities, or have to invent a way to do things that they've done before and essentially relearn very basic things. So we know for a fact that there's quite a bit of hardwiring. So if you are going to try to get rid of biology, the minute that you're going to start touching vital organs, you're pretty much playing Russian roulette with all the bullets in the chamber and hoping that something jams.
George, what would you say about that?
A couple things. Well, first of all, to say that we can, I guess, transcend our biology can mean many different sorts of things. So, for example, one of the visions that I foresee, for example, can be the complete cyborgization of the human body. So that doesn't require any kind of uploading or mind-to-machine transfer. So I think the automatic inference to singularitarianism is not necessarily fair. Secondly, you can still have kind of an experience of being outside your body through such things as virtual reality experience, like a fully immersive virtual reality experience, whether it be something as simplistic as even some kind of a heads-up display, or something that's portrayed, for example, in The Matrix, where you're so-called jacked into a machine. That's certainly within the realm of possibility. But even one of the more elegant solutions that I've read was Ray Kurzweil's nanotechnology. His basically like a nano array in the brain would basically shut off all of the incoming environmental stimuli, and in its place relay a fabricated or synthesized environment, so that you actually feel that you're in a completely new and immersive virtual reality. You're still wholly biological, like you still have a body in the real world, but you are, for all intents and purposes, existing in a different environment altogether. So those are kind of avenues to, I guess, a virtual kind of uploading that don't require the true uploading kind of paradigm. Now, that said, and first of all, just for the record, I don't know whether or not we're going to be able to upload the human mind. I don't think anybody knows at this point. Consciousness, as Greg conveyed, is still very much of a hard problem, and we're not really sure how to actually get from here to there. But one thing that I'm becoming more and more sure of as time passes and the more I look into this is that, the brain, it's not a magical object. There's nothing mystical or magical about it. It is a machine that computes. And this was known as far back as the time of the Enlightenment, when Condorcet, he basically said that basically it's matter, the mind is basically matter that thinks. And we just have to figure it out. We have to figure out what every organ in the brain does, the so-called conscious correlates of the brain, what they do, map it out, and create a digital analog for it, which may or may not be possible, but I'm tending to think that actually every function that is within the brain can be synthesized in a digital substrate. Right now, it's the substrate happens to be meat, but that doesn't necessarily mean that the same kind of processing that happens in the brain. And one has to assume, of course, that have to assume the functionalist model of the brain. And what I mean by functionalism is basically the idea that exactly that every component of the brain, no matter how far you drill down, is functional in some sort of a way that can be understood and therefore modeled and replicated in another medium, whether it be, like I said, cellular-based or carbon-based, or whether it be digitally based. So it may seem pretty intractable from here because we're still struggling with a lot of issues in terms of how the brain works. But I'm still kind of, I think the jury is still very much out on ruling out, for example, the whole uploading scenario.
Greg, where are we in artificial intelligence right now? Like, is what George saying realistic?
Actually, a lot of the things that I hear from very vocal proponents of a lot of trendy transhumanist thought sounds sort of like an old joke about a pig and a chicken that are walking down the street, and the chicken sees a particularly promising storefront and says, "Hey pig, why don't we open a restaurant?" "Okay," says the pig, "what are we going to call it?" Chicken thinks for a second and says, "How about eggs and ham?" Says the pig, "It sounds like I'd be committed, but you'd be only involved." So this the way that I'm sort of seeing what's going on with transhumanism today is that it's sort of outsourcing some of the more difficult ideas to computer scientists and saying, well, if we do all this cool stuff, we should be able to, we should be able to make it happen. We should be able to make it a reality. But in the real world, a lot of things like creating an artificial intelligence is extremely difficult. In terms of where we are with artificial intelligence, is basically we're just starting out. We're just laying out what will we consider to be an intelligent agent. How do we actually make it? What is actually involved? And there's still numerous competing models that are currently focused on very specific tasks. For example, you would have one agent that's focused on image recognition, one agent that's focused on contextual recognition, a machine that can understand sarcasm, a machine that tries to write jokes. All of this right now is separate research that's not really being combined. It's very, very difficult, and the most optimistic estimates that I've heard about having an actual system that humans can interact with and they could actually even hope to pass the Turing test is about 30 years out.
And just explain the Turing test for our listeners.
Well, the Turing test was developed by Alan Turing, who actually gave us computing as we know it today, or rather the theory of computing as we know it today, or I should be a little bit more specific, the foundations of it. And the Turing test basically says that if you have a human talking to a machine or another human via something that we could call IM, if that human can't tell the difference between a fellow human and a machine speaking to him, then the machine should be reasonably intelligent based on its interaction. Now, there are a number of criticisms from a philosophical standpoint, but I think that if we could actually make a machine that can interact with a human, they can understand language, and they can talk back consistently and hold up its own end of the conversation, that's already a gigantic feat. And very few people are even close to this realm.
If I can just interject here a little bit, just concerned in a way some of the generalizations in terms of the transhumanist approach to the AI problem, and to say that they've all kind of offsourced this to computer theorists is, I think, a bit of a misnomer. I just got back from the H+ Summit at Harvard, and I'd say a good half of the talks there, if not more so, were in the field of neuroscience. And they had absolutely nothing to do with computer research or even computer theorizing. And basically, where the model is moving to now is not to kind of think that you can hard code this in the way that Greg was describing, and basically work on an agent by agent or module by module perspective in terms of how you could code this algorithmically, but rather looking at this point to reverse engineer the human brain, or what is also referred to as whole brain emulation. One of the leaders in this field is Anders Sandberg, who's based out of the UK, and I do believe that Ray Kurzweil's next book will actually be about this exact topic here. And why it's a particularly appealing model for moving forward in terms of dealing with modeling the brain outside the human body is, well, we have a working model already. Not only do we have a working model in the human brain, but we have the genome. And with each passing year, we're able to read the genome with greater and greater accuracy and sophistication. And we've come to learn, for example, that half of the genome is devoted to the construction of the human nervous system. That's half of it. That is a massive amount of data. But the blueprint is there. We just have to figure out how to read it, and then how to recompile it, how to go about understanding genetic expression, how to know when the genes turn on and why at certain stages of the brain's development. Basically, we've been given this map, and I think that is where I think some of the emphasis now is shifted in terms of this kind of research. So I do think that this has happened, I think, in the last 2 or 3 years now, is this kind of shift away from pure faith in the computer researchers to figure this out, and basically realizing, you know what, we're going to have to basically understand how human mind and human consciousness and human cognition works if we're going to get to solve this problem.
But the singularity is brought up quite often by transhumanists. Would you actually just give us a brief definition of what that is? Because we've received quite a ridiculous number of questions specifically about the singularity.
And just for the record, obviously, one does not need to believe in the quote-unquote singularity to be a transhumanist, and not all transhumanists certainly take that particular perspective. But you're absolutely right. Many transhumanists do talk about the so-called singularity. And what that is, and why it's called the singularity, it's basically the point, the hypothesized point in the future when we will develop not just an artificial intelligence, but we will develop an artificial intelligence, or it could be a multiplicity of AI that have greater than human cognitive capacity. But it's more than even just that. It's that they can recursively go about self-improvement. So they won't just be a little bit smarter than us. They're not going to have IQs of, let's say, 180, 200, or whatever. They will actually be an order of magnitude more intelligent than us, and have access to, of course, all of the resources on the planet, whether it be material resources or informational resources, and they will crunch this data at an absolute astounding rate. And you have now debates about whether this will happen very quickly or very slowly, the so-called hard takeoff or slow takeoff scenarios. But why it's called the singularity, and it's actually a term that's been adopted from cosmology. A cosmological singularity is that point where, with a black hole, as you know, a black hole, nothing can escape it, not even light. So there comes a time when what's called the singularity point is where you can't see past it. And that's exactly what this is from an historical or future history, I guess, is that we cannot see past this horizon, this literal event horizon, because we don't know what's going to happen afterwards. We don't know whether this AI will be poorly programmed and malevolent, or just indifferent and destroy everything, or have some kind of confused goal architecture. And again, it's kind of important to realize that this kind of an AI, or what's called an SAI for super artificial intelligence, doesn't necessarily need to be self-reflective or conscious. It can be an expert system, much like Deep Blue was an expert system. Deep Blue, of course, was the chess machine, and all it knew was how to do brute calculations in chess. Similarly, this could be a kind of machine that doesn't have any kind of sense of self at all, but simply knows how to act upon a goal. So the idea here is that it's going to be so powerful that it will be able to act on any goal that we give to it, and it might actually misinterpret that goal and go about destroying its environment or us in the process. Other scenarios, of course, are that it'll actually just disappear and bugger off, and we'll never actually see what it was. And other scenarios are that it might actually, some more, I guess, techno-utopian scenarios suggest that it will solve all of humanity's problems and create a kind of utopian future world where we'll all live, happily ever after. And it's difficult. I mean, obviously, everyone has an opinion on the matter, and whether or not we should even speculate about that or what they think will happen afterwards. But ultimately, we really have no idea at this point what's going to happen after a singularity.
Greg, what's your opinion on that?
It sounds pretty much like all we have left to do is everything. I mean, just figuring out exactly how the nervous system is built, protein by protein, is a task that's going to take a very, very, very long time. But in terms of having a computer intelligence that's superhuman in some way, one of the things that kind of irks me about it is that today's computers, today's machines, today's robots are all an extension of our abilities. They, by definition, do certain things better than we do. The problem here is that we are programming them. We're telling them what to do. We're telling them how to do it. And even when we're going back and taking a look at neurology, and I have to say that computer theorists are actually extremely interested in neurology. You get a bunch of people today who are working on computer science research and talk about AI. Half the time we're going to talk about biology, how neurons work, what information neurons contain, how they're built, and how we can better emulate them. So I can assure you that that's certainly not a neglected area of attention in computer science today. But like I said, when we build machines that are extensions of us, that automatically do things better than we do, we should probably not necessarily call them superhuman, especially when they're essentially tools that we can control and we know how to control. And quite honestly, if they don't have any sense of self, and if they're simply following a certain goal that we've set up for them, we could technically call it intelligent under certain definitions, but at the same time, I really doubt they would decide to suddenly rebel against us unless it was actually told to do so. But we would be getting into a completely different problem, which would probably take a whole nother show to discuss.
Speaking of a whole nother show, I have at least 15 listener questions here, and we are not going to get to them at all because we have 1 minute left. I'm going to ask you right now to both return to the show at some point because this is a fascinating conversation, and I don't think we can do this in one episode.
You got it. It would be my pleasure to come back. And you can even devote the entire hour to audience questions as far as I'm concerned.
We could do that right now, actually.
That sounds excellent, and I would certainly be up for that.
George, Greg, fantastic conversation. Thanks very much for being here today.
Thank you.
My pleasure.
So do check out Greg's site at worldofweirdthings.com, and George writes at sentientdevelopments.com. And we, as always, are at skepticallyspeaking.com. Click the links to show your support on Facebook, on Twitter, or iTunes, where you can subscribe to the show. Thanks for listening, and we'll see you next week on Skeptically Speaking. On Skeptically Speaking, we do interviews with experts on everything from vitamins to paranormal research to evolution to nuclear power. But we also do interviews with people like you. Maybe you've done some research into a specific alternative health treatment and you want to share what you've learned. Or you've written a blog post on some questionable story that's been in the news and you think that people should know about it. Or you've found a creative way to talk to your children about science and you think that it could work for other parents. Or there's a skeptical project that you've been working on and it's time for some promotion. Perhaps you've had an experience where critical thinking saved your bacon and you think that the story might be valuable to other people. These are all great topics for speaking up. You bring the idea and we'll work with you to make sure that your piece is radio ready. Just send an email to feedback@skepticallyspeaking.com. Put speaking up in the subject line, give us a bit of information about your topic, and we'll contact you. All of us here at Skeptically Speaking are committed to spreading the wonders of science and critical thought. We want to encourage your efforts, and in turn, your segment encourages others. Because we all need some support, and a gentle nudge now and then, to keep questioning everything.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell, gonna raise a little hell, break the spell of Pavlov's spells. Cause we're skeptically speaking, our mind reading tarot cards and witches, psychics, and their spoon bending mind tricks. All the humbug, flim slam, frauds and shams, the charlatan woo. I don't think you understand, it's the hocus pocus, out of focus locus, eroding the brain, making gains on the hopeless. Let the crystal ball fall, smash on the floor, leave the pieces alone, we don't need them anymore. Just a microscope, telescope, magnifier, reading in between the lines of these lies. Bring it on, the skeptics await your letter, your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is, cause we're skeptically speaking.